Hello there, it's me Rama, and this is going to be a demonstration of the Rama Patrol component that I'm giving to you. There is C++ involved, but the component is designed to be extended in blueprints. In fact, it can't even be used unless you implement some blueprints that will basically decide how the character moves and also the logic for switching points. I do provide a default setup that is easy to use, which I'm now going to demonstrate after I finish getting really happy from setting that thing up. Whee! Alright, I'm coming, I'm gonna be serious. Alright, I just have to go see the rainbow thing for a second. Hi, rainbow thing! Look at all the little particles dancing everywhere. Alright, okay. I'm ready to be serious now. Hey, what's this? Kabam! Okay. Oh wait, I have to show you. You want to see a slick move? Watch this. Ready? Oh, that didn't work. That wasn't my slick move. Hold on, I'm gonna try again. No, that wasn't it either. Ready? 1, 2. I missed. Whee! Okay, and landed it. See? I'm up here now. Nobody can see me. Alright, I'm gonna shoot these things. You know what's about to happen, ready? Sorry, I couldn't resist. Okay, I'm ready to function now. So yes, you can see this girl's off on her own patrol route, right? She's doing her own thing. Where did she go? There she is. So, if you watch, if we just follow her for a second, she's got a completely different route than the other girls. That girl's going somewhere else. Alright, so that's a demonstration of her route, right, that you see her following. And again, everything you're seeing, I'm giving you this project, so you'll be able to just start with this setup that you're looking at and extend it as you wish to get used to the component. And then you can bring the component into your game because it's in the plugin. Okay, alright, that was my last explosion fest, except I have to do it one more time. I'll get over it one day. I don't think I ever will, but okay, last time. Whee! Okay, alright, I'm ready. Okay, so how this works, we're going to start in the C++ because this is actually a C++ tutorial, but if you don't know C++, you can just enjoy this part, but the component that I'm demonstrating for you is a component that you can use without any C++. That's kind of the point, right? Is to make a C++ entity extensible in blueprints, easy to use, and highly versatile. So that's what this component is. As you can see, the very first 5 lines are among the most confusing to people who are coding in C++ but aren't used to delegates, just because the syntax is a little unusual. The reason I include the component herself, I'll just say her, I don't want to say itself, is because it's just an easy reference in blueprints. Once the component event is received, to just immediately have access to the component. So you'll see in the C++, wherever I call saying this, right? Because I'm just including the component. So you know, this is standard practice in the engine, you'll see, especially if you look in primitive component.h. So this is an extensible component, and I'm showing you how I do the extending of components with the goal of basically encapsulating a set of functionality that is going to be useful in any project. It could be any set of code, but this set of code is focused on Joy Patrol component. So please observe the most basic aspect is, of course, making sure that the system is very efficient, and that is just using set active and is active, basically tick. So turning tick off whenever the component is not in use. Now why does the component need a tick function? Because the job of the component The core of patrol logic is to know when to switch points. When has the unit reached the desired point? When should we switch? And that's basically a distance check for our current move goal. Now, where is the move goal going to be set? That occurs inside of choose next goal, and I do not implement that. That's a blueprint event that you implement. You decide the logic for switching points. Again, I do provide a simple default implementation that is easy to use. So you can look through the component. I comment everything. It doesn't make for the most exciting YouTube video to just flip through code though, but it's all here, and I give you all the code and I give you the project so you can check it out. But the core concept is that there's two different modes. There's follow mode, which is if you have a follow actor, if a target is set to follow that unit. And then there is following path points, and also waiting at positions for a chosen amount of time that the user can choose in blueprints, or in C++, you can decide. So this is, again, the concept of extending actor component to then encapsulate a set of C++ logic and then make it extensible in blueprints. That's the chain of events the chain of concepts that I wanted to emphasize. Okay, now back into the land of blueprints. So the AI character has the component. It's the Rama Joy Patrol. You can add it if you just look for Rama, and you'll find that right there is the patrol component. Again, I tend to comment lots, and you'll see a lot of the component is commented for you. But the basics are here. So once you've added the component, you need to implement these events, right? Now notice in this green crystal AI class, these events are not implemented because the green crystal AI unit is not meant to move. She doesn't move, she just sits still. So the only thing I do in the constructor script is I turn the component off because it's not meant to be used by green crystal. But that's just her thing. Then I subclass green crystal because she's like the base class of the AI. She doesn't move. I implement each AI logic in phases for you so you can see the phases of AI development. Now but the green crystal does have target. So let me go back to blueprint. So you see crystal target, right? Actor. So that's the target unit. I say crystal target. Crystal's like my word for AI. It has meaning to me. Take a while to explain, but the idea of crystalline logic, crystalline being, thinking very clearly and concisely. So this is the AI target, the target of the AI unit. Yellow crystal implements green crystal, and when the target is set, I update the component's follow actor. If you recall, in the C++, over here, I say if follow actor is valid, not equal to null, then follow and then exit, right? So this code block is a hard return if we have a follow actor, and this is the following logic, including if the unit gets stuck. So, and that's really important because that does happen, let's admit it. AI units do get stuck on patrol or if following an actor, and if stuck, what to do. So now we come to the interesting part of implementing this component. You have to implement these events. You see them here, and you have to implement the ones that you want. And note that when the target of the AI is cleared, you should also clear the follow actors, so it's consistent. You can basically just clear the target and she will go back to following a path if there's a path set up. Now let's focus on choosing move goal. If you notice, I have something called a joy path. What's that? Thank you for asking. Let's go see joy path. So in the plugin, there's a content folder. In the content folder, there's Joy Patrol, and there's this thing called a Rama Joy Path. Rama Joy Path is pretty simple. There's not much going on. The most complicated part is actually the constructor, which is to ensure that the first point is always the location of the patrol actor. The patrol actor doesn't have any components. There's only one thing really, which is the path points, which are a vector. Now please note something pretty exciting. I thought this was exciting. One of the features that I was very happy about in UE4 that isn't talked about that much. Please note that you can see these path points, and you can even click on them, and it's really easy to set up. So here, let's make a new pathing. I think I'll start from scratch. So let's make a unit that's going to go up on this ramp, go around, come back, all that sort of thing. Ready? All right, let's do this together. This will be fun. So let's head over here. So this is from the plugin. So you have this at your disposal. It's not project specific. It's in the plugin. Now notice path point 0 was already set, and that's because I did that in the constructor. It says 0, 0, 0 because it's relative. The path points are relative. But let's see, where is our first path point going to be? Let's say this lady likes to start. This is her starting point. Okay, she starts right there. Now let's get path point 0 is always set by me. Let's add a new path point, and now let's click on the little blue triangle thing, and let's move this point around. Now, how am I doing this? Is this magic? Yes, but it wasn't magic created by me. Not this part. This was done by Epic. I love this. The fact that I can just easily add points like this. So I'm going to add another point. Go over here, grab it, and I'm going to stick that point over here onto this part. And I think the navigation system will figure this out. That's pretty close. Okay, let's add another point. You see how easy this is? Why so easy? Because Epic, that's why. And I'll explain why in a second. So let me I'm having fun with path points now. So the other thing I'd like her to do is I'd like her to go all the way over to this point here, right? So that's what we're going to do now. Okay. Are we level with this thing? Pretty good. Okay, so she goes from one ramp there, and then she goes all the way over to the other ramp. Alright, that's good, right? Let's leave it at that. Now let's name this thing so we don't lose track of it. Or her. Again, I'll call everything her if I need to refer to it. So this is path point 3. That's good enough. Let's leave it like that. But we need a unit that's going to follow this path, and I don't want to disturb the existing arrangement. So I'm going to grab this girl. She is now multiplied, and she's going to go over here. Actually, let's have her start somewhere you can see at game start. So she's going to start on the ground. Okay, and she's going to go right here. Okay, so she starts there. And now, how do I set her to follow that path? Well, this is implemented in blueprints, this part. So if you look for green crystal, sorry, if we look for yellow crystal, if we go to yellow crystal has a variable called Rama Joy Path, and that is that plugin actor. And notice it's got the eye thing, which means it's exposed to blueprints, which means you can easily set it per unit in the level blueprint, which is the fun part, because now it's C++ blueprints and level blueprint all weaving together very happily. It's called UE Gaming, UE Game Development. Yay! Joy of life. Game development in Unreal Engine. So here you see, now this unfortunately was put in the default category by me, so we're going to fix that because that makes it hard for me to find later. So if we look, I have a very specific naming scheme for my categories. So now, like if you're puzzled by the massive stuff, you can just type Joy, and you'll see Rama Joy Path, and she's set to follow the first one, but let's set her to follow the third one. Alright, so she's now been set to follow the new path. She's not set to target the player, so she will go off and do her thing now. Alright, let's see that in motion and in life before we move on to what we're doing. Okay, so there she goes. Look at her go. Now you see she's firing as she waits at each waypoint, right? That's my choice. I was just goofing around with what happens at each waypoint. So she's pausing here, there she goes. Up the ramp. She's doing it, right? Basic patrol system already working. I did all the hard work for you. You can just have fun and efficient too. Yeah. So they don't have to wait at path points. That was just me goofing. The default implementation is they don't wait at path points. They just keep going. But there you have it. All done now, right? Let's watch her. Oh, I can't resist. They're here. Ready? 1, 2, 3, and go! I wonder where she will be. Oh, she's fine. No, that's the other one. Did we lose her? Is she gone? Will she ever come back? Oh, there she is. She's back. I don't know where she went or how long it took her to get back, but she's back. Alright, so that's the basic implementation of a path point or a pathing system. So in this actor, again, part of the plugin, the only really essential function is to get the path point in world space, which is important because you're not going to be able to use it otherwise. So to do that, if you look, the path points are in local space. Right, now to get it into world space, I just get the actor transform, which is the path actor, right, the root of all the path points, and I just say transform location, providing the relative path point, and that converts it into world space. So maybe this should say transform location world space or something like that, but you know, it's this is how it works. There's one interesting point, which is that I do an index check, so this is going to be called by you or by the AI unit because of you, because you'll train the AI to do this. And if you give a bad index, got to check for that. And if there's a problem, I go to 0. Now I know 0 is guaranteed to exist because of this. This is the constructor, so I don't have to check if 0 is valid. That's it. There's nothing else to it other than current path index, which I don't think I'm even using. I know I'm not even using that. So that's it. There's nothing else to it. Okay? Alright. So, now, how does this work inside of the AI unit? So, the component checks for next move goal. That's me in C++ saying to you, okay, in my logics, in a path following situation, I'm ready. We're not waiting at the goal. We have a goal, that's great, or we arrived, we're not stuck, we're ready. I'm ready for the next path point. So in that case, I check if there's been a valid path. Again, you have this actor, and then this part's just me having fun, choosing some values for how she'll animate as she waits at each path point. But the main part is then, now you know what this is, get the path point in world space. The AI unit has to have the path index because each AI unit could be following the same path and they'll be at different indices. You can't put this on the path itself, herself, because then everybody will be changing the same index. You know how I know that? Because that was the mistake I made when I first set it up. Don't tell anybody. So, has to be each unit having their own path index that they increment as they see fit. So you see here I'm incrementing the path index. Now if they reach the last point, I check here, should reset index, that's checked in here. So if the path point asked for by the AI was invalid, I use 0 and I tell the user, to reset the index. You reach the end of the path, basically, right? So if you should reset, if that's true, the local unit resets her path index and she loops. Now, otherwise, continue to the next point, right? Again, these values, this is me goofing around. Well, this is how long to wait, and it's a random value that I expose to blueprints so that each AI unit can behave differently, waiting for different amounts of time. Another very important variable to keep in mind for this patrol component, one of the most important values, is the This is if they're following a player, at what distance should they stop? So in a melee game, this would be very small. But if you have ranged things that you're using, like projectiles, you can have the unit stop when they're still far away, because they prefer to keep some distance. Now here, the move goal radius, very important. How close does the unit have to be to decide they've reached their goal? Now the reason to vary this is especially important if you have many units following the same path. They shouldn't all stop at the same point. So you can have them avoid each other easily by just changing the radius. Some will stop further away, some will stop closer. That's great as long as they're not on a narrow ledge, but if you have many units following the same path, it comes down to game design. But this basically decides how close they have to get to the goal. That's really affects the behavior of the unit. Then, again, if they get stuck, what should they do? Well, if they get stuck, I fire off an event for you that you can call here. The path, I attempt to skip the path point where the player or the unit got stuck and keep going. And if that happens, I report to you, oh hey, this unit had to skip a path point, please get me the next point. But if they got stuck, I inform you. Now, you could decide that you want to jump or attempt to, in some other fashion, get around the stuck point. You can do that here, right here. So, but let's say that you don't want the unit to just skip to the next point. You just want them to stay stuck until you figure it out by telling them to jump or something else. That's what this is. Move to next point if stuck. Now, for everyone, C++ or not, it might be fun for you to see some code. This is how this works. So if they should go to the next point, I check. Alright, are we stuck? If so, then go to the next point. Move on, right? Okay. So, heading back over here, the last point of interest is if they're stuck while following the player. This is where I, in a different video, demonstrated them getting stuck and then getting around it, perform a stuck jump. They try to get over the hurdle, whatever's blocking their way. And I do this through a vertical jump, a vertical forward jump toward the player, toward the target, but also a sideways jump just in case. But I only do the sideways jump 77% of the time. Here's an easy way to do something 77% of the time. Random float in range. Alright, so you have the basics now. Choose a point. The logic is implemented in blueprints with this Rama path actor. Then move request is me requesting you to make the character move. That was also covered in a different AI video that I did, where I created a function to find the path along the navigation mesh, and this is a C++ function that I created to assist with this process to get the unit to move toward their target goal. Now, if you have a different kind of game where characters are not on the ground, you can implement all these logics yourself in a different way. You have this whole project, so you can see how this all works and ticks and talks together happily. But that is the basics, and as a final demonstration, let's do the stuck jump thing, and then I'll conclude the video. Okay, so I'm going to turn her on. So she's the one who, just the unit I decided will chase the player. And look how I just went through a really, oh, she went right over it. Okay, look at her. So here she's stuck, right? See how she just jumped and made it over, right? That was a stuck jump. She was stuck, it's true, but now she's free. Alright, Alright, that's my noise when an AI unit gets me. See, there she jumped again. And now she is good to go. Yay, good job, you did it, you did it. Alright, okay, last time demonstrating my sneaky, I call this a very dangerous jump. Ready? Oh, okay, and whee! Alright. What you gonna do? Okay, that didn't take very long. Well, we're over here now, so that's cool. Ah! That really is my nose when I... Okay, that's when I jump really high. I'm learning all these fun things I didn't know about myself, because I never notice these noises I make until I'm recording. Okay, demonstration complete. Hope you enjoyed this little demonstration, and I hope you have fun using this component in your own project. How did you get up there, dear? And kapow! Okay, demonstration complete. I hope you enjoy using this component in your own projects. Enjoy!